thank you very much for your time today. My name is Brian Proffitt. I am a community liaison at Red Hat. I currently work on the OVERT project. Wait, where are my dancers going? Oh, you're going around the room. No, you should stay up here so everybody can see you. So anyway, I'm going to be talking. I have also been involved with the launch of Project Atomic, which was launched at Red Hat Summit this summer. And so I will be speaking to you about that today and talking about sort of the broader sense of like the hype cycle and why things need to sort of get some management behind them. So to begin, a brief history of operating systems. 14.798 billion years ago, we had the Big Bang. And out of that, we had hydrogen. Yeah, you didn't think you were getting this today. So you had hydrogen, then you had stars, then you had supernovas, then you had generation 2 stars, and then you had, you know, all the other elements, and they all came together. We had carbon and iron. And are you keeping up? They're not even keeping up. Seriously, who hired these people? You had all this stuff come together, and we met, you know, the sun, the planets, the moon, the stars, everything came together. And then, you know, some of these carbon-based life forms came together and decided, hey, let's take a whole bunch of this metal, the sand and the metal, and let's put it together and do some mathematical stuff, and we'll build something called a computer. And on this computer, I said it was a brief history. On this computer, we needed to talk to it because we don't talk in binary. We talk in weird, you know, floaty terms. You know, we had to do, you know, we're dealing with binary stuff. So we invented the operating system. And in that 13.798 billion year history, one life form came along that actually is here today, and it's her birthday. So please join me. Happy birthday to... I'm not singing. Sucker.
Happy birthday to you.
Thank you. 29 feels very good again. Payback. Oh, payback.
Yeah, this is my last public presentation ever. I'm going to be dead soon. Thank you. Thank you both very much. So, yeah, they thought they had me. But the laryngitis is real, so please bear with me on this. So, moving on to our talk. We live in IT in a very OS-centric world. Operating systems are the center of our universe. They have been that way pretty much from the beginning. Just like people used to think that Earth is the center of the universe, and in some respects, like, you know, Mr. Universe and Miss Universe, we are still the center of the universe because the rest of the universe is zero. Suck it. Right? Come on. Not that I'm going to be Mr. anything, but okay. But in IT, it's still been a very operating system-centric world. And, you know, we've made this a little easier because we've had virtualization, excuse me, and we've abstracted the operating system away from the hardware. That's what virtualization has helped us do, okay? And then after we did some virtualization, then we got better at managing it. Then we got an idea in our head to say, hey, let's let the applications sort of self-manage their resources a little bit. So that led to cloud, you know? And I'm highly abstracting at this point. But, you know, virtualization and cloud were the first steps towards turning, you know, physical machines into virtual machines and you know, getting away from, you know, zillions of dollars of hardware racks in a, you know, heavily air-conditioned data center somewhere. Okay, it's not just one operating system for one machine anymore. You know, we've gotten a lot better at it. But at the end of the day, we are still dealing with operating systems. No matter where you go, there you are, said Buckaroo Banzai. Everything we have to deal with is still around operating systems, whether or not it's in a virtualization cloud, virtual data center, or a cloud situation. We still have to update the operating system. If you're an admin, you have to babysit this thing. If you are a developer, you still have to code your applications for the operating system. And God help you if somebody does a security update and suddenly your application says, check please, I'm done. These are things. This doesn't change at all. Except now, here comes containers. That's actually built out of shipping containers. I thought it was kind of cool. But anyway, containers change everything. Now, containers have been around for a long time. I know everybody's like, ooh, Docker. Okay, and I'm not knocking Docker. It works, and it's cool. But containers have been around for a while. BSD has them, they call them jails. Solaris has them, they call them zones. The Linux kernel has them built in a tool called LXC. So, Docker has kind of come along, and it's the new kid on the block, and it's got some cool stuff, and I'll talk about a little bit later. But, containers are not new, but now people are starting to pay attention to them. Because containers offer us something that is really interesting. Now Earth isn't the center of the universe. Now the operating system isn't the center of the universe anymore, potentially. Like this old medieval diagram, the sun is the center of the universe. That's not exactly true either, but give them a break. It's the 12th century, okay? But we've shifted our focus. This is a heliocentric model. We now potentially have an app-centric model for IT. Because if you are not familiar with how containers work, excuse me, basically they are files, they are hardened namespace bits on your system that will basically allow you to take an application and run the application and only what that application specifically needs to go. You don't need it. It's not virtual machines, although people tend to think of it that way. You can put the entire operating system in the container if you really, really wanted to, but you don't have to. You just have to put the libraries and files that are needed that the application that you're building is dependent on. So that makes your life a lot easier because now you're just coding for your app, And who cares if Java is changed on the baseline operating system underneath because you're pointing at a specific instance of Java either inside your container or over here in a privileged container that you're keeping an eye on. So now as a developer, your life becomes a lot easier. And this is why containers are mostly awesome. This is where some of my natural conservatism about IT comes into play because I'm not going to be the guy, even though I'm working for an operating system company and we are pushing this new cool container-like tool called Project Atomic. I'm not going to be the first guy in line to say, woo, containers are the most awesome thing ever. Like any other new technology, there are issues. Here's what containers help us do. They help us get around traditional packaging issues. They have a number of advantages over virtual machines because, like I said, whether a machine is real or virtual, if you have to manage it, and with all the different security updates and all the different bugaboos that an operating system has, it's still, you still have the same level of IT management. Excuse me. So now containers make that life potentially a lot easier. But a traditional operating system is kind of an overkill for running a container, okay? And right now, Docker is the hot new tool for containers, and Docker is excellent, but it doesn't really have any built-in management tools, not really. I mean, you just bring it up, you bring it down, you start things, you install things, you go, but that's basically it. We are in early days. And a lot of what we see with containers right now is what I used to see when virtualization became a big deal, where we have virtual machine sprawl. I need this, I need a test machine, woo, virtual machine. I need a production machine, woo, virtual machine, boom, boom, boom. You didn't have any proper management tools, suddenly you've got 5 billion virtual machines, slightly exaggerated, but you've got them sitting around your IT data center. And you're like, what? Same thing with containers. Excuse me. So here we go. This is where Project Atomic comes in. Now look at this graph, or this cool little graphic here, and now forget it, okay? Because this is how fast Atomic is moving, and I'm going to actually point this out later. Some of these tools are here, some of them are already gone, and this graphic is only about 3 months old. So this, we are rapidly evolving. But here's what Atomic is meant to do. Atomic is a set of tools designed to create proper host for containers and manage them effectively using what are known as atomic techniques. Now, usually when people hear atomic, they think we're making some kind of play on the containers themselves, that the container is the atomic nugget. That's actually not the case. Okay? This is Project Atomic is an upstream, community-oriented project designed to take existing tools like RPM-OS3, Cockpit, Kubernetes, and Docker, and SC Linux, and Systemd, and once upon a time Geard, not anymore, told you it changed, and take all these things and build something that actually works for container management. This is what Project Atomic is not. It is not a new distribution. It is not a new operating system. It's still basically a RHEL or CentOS or Fedora, or when the other distros jump on board, and I'm happily waiting for them to come in, then it will be any distribution. It's a set of tools that sits on top of these distributions, okay? And we currently are working on 3 different hosts, CentOS, Fedora, and RHEL, okay? And as you've seen, Atomic is not set in stone. We've already changed our orchestration tools, and we're talking about changing them even now. So, I'll tell you something today, and it will be gosh honest truth, but 2 months from now, the tool set may evolve. And this is why we're rapidly encouraging people to get on board the community, especially now that we have some stuff to show you, which I'll demonstrate later, and get involved in this and watch this thing go. It's a very rapidly changing system, and we're looking for community involvement. So what an atomic host, whatever flavor it is, needs to do, it's going to be providing a streamlined host for Docker containers. Okay? Those hosts, the atomic hosts, are built from distributions you're already familiar with. So if you are running a RHEL-based system, and forgive me if I say RHEL-based, I'm not putting on my red hat here and saying, buy RHEL. I'm actually, usually, since I'm a community guy, I'm like, use CentOS, because that's better for community upstream projects. But in generic, if I say RHEL-based, just say RHEL, Fedora, CentOS. And forgive me because I have the laryngitis and I don't want to say that 50 times. So you have these trusted RHEL-based distributions that are set as these atomic hosts. Excuse me. And they will provide that orchestration and a lot of other features for running containers at the scale you need and keep them in line and keep them secure. These atomic hosts will be very small. You're going to have to run applications not on the underlying host, but you'll run your applications inside the containers, okay? And we're working hard to get these atomic hosts down to a really nice minimal size. So basically, just enough to run containers and container managements. And we're doing that with tools like OS3, and then beyond that, RPM OS3. Now, OS3 was initially developed for GNOME. If any of you are familiar with the tool called GNOME Continuous, which was an image-based management system for GNOME desktops, that's where OS3 came from Colin Walters, who is a GNOME developer, also works at Red Hat. Okay, RPM OS3 came from that. We took the concepts of GNOME Continuous and basically applied that to RPM package management way before Docker came along. And the easy way to think, the glib way of thinking about RPM OS3 is I say, oh, think of it like Git for binaries, okay? That's an oversimplification, but it sort of works. Where with Git, with code, you push things out. If there's an issue, you roll them back, okay? Same thing with RPM OS3. RPM really goes one way, forward. If you do an RPM-based update with Yum or whatever, it's hard to roll that back. But with RPM OS3, you can, because you deploy things, packages, in single atomic, that's where it came from, single atomic images, okay? If it out to all your hosts. If it works, boom. If it doesn't work, one command and it's rolled back. This also not only allows you to roll out updates, but theoretically, you could roll out entirely new operating systems as you're in your host environment. You could, in theory, change a Fedora atomic host image to a CentOS atomic host image and change it all out underneath. I don't know why you would do that, but theoretically that's what you can do. You create installable trees with RPMs. It's not a package manager. We're not getting rid of RPM. We're supplementing it. And using RPM OS3, like I said, you're not going to be able to install RPMs on the host, okay? You still have to run your applications that you need in containers on top. Another tool that we have inside Atomic is Cockpit, and I'll show you this in a little bit in the demo. Cockpit also started prior to Atomic. It was actually a GUI-based server manager that you could do, from your browser. It doesn't mess around with any other admin tools you have running in your data center, and it's designed to be multi-server, and it can also keep track of now containers. So it's a really interesting container management solution that's GUI-based. Also, obviously, we're using Docker. Docker has not been around very long. It got started in March of 2013, so it's just not much more than a year old. It was built around Linux containers, or LXC, and those have been around for a while. And as I said, very application-centric, and they have good versioning. And the thing that Docker brings to the table that other container systems don't have is that you're portable. So theoretically, if I have Docker systems, and I have a couple of containers over here on this Docker host, then theoretically I can take this container and move it over to another Docker host immediately. No muss, no fuss. Done. That's what Docker brings to the table, that portability. And that's why it's so interesting to a lot of DevOps people right now, organizations. And it also will help you, because people are so involved in it, we're seeing a lot of Dockerized applications and services, because you can take your entire service or application, get it inside of container, put it on the central Docker registry, and you can just immediately download that sucker and run it as a full service on your Docker-based system. And then also we have inside of Atomic, we have orchestration. And we have a lot of different orchestration tools. Cockpit is one, okay? We initially had GearD, which is an OpenShift tool. And we were going to incorporate that into Atomic and have that be as GearD manages OpenShift gears, we were going to have GearD manage containers within Atomic. But soon after we started the project, excuse me, we decided that we would go another direction and work with Google Kubernetes. And I'll focus a little bit on Kubernetes, but there's another orchestration tool that we have in there as well. So Kubernetes is a Google project that was originally designed to manage containers, not necessarily Docker. It works on a master minion model, so you have to have at least 2 hosts to get it to go. It uses etcd to store configuration data. And it is a brand new project. And basically, Kubernetes is what lets you manage a single application across multiple containers. That's how it was basically outlined to me, and this is what I usually share with audiences such as yourselves. Another orchestration tool that will be inside Atomic is Apache Mesos. And Mesos is an orchestration tool that lets you manage containers across multiple hosts. So you got Cockpit doing the individual containers, you got Kubernetes doing, applications across multiple containers, and then you have Mesos doing containers across multiple hosts, and so on and so forth. Is that where we're going to end up? Right now, that seems to be the best play. We may work with that. By the way, for those of you who are paying attention, notice that with the exception of RPM-OS 3, which was initially designed for GNOME, but the lead developer just happens to be a Red Hat employee, all of this stuff is built outside of Red Hat. So this isn't Red Hat coming along and saying, oh, we're going to build something really cool and throw it out there and see what happens. No, we're taking tools that exist already and pulling them in and consuming them. And we think that that's really a great way, to do this. Use the existing open source infrastructure, pull them together, and make that a unique management host. And with Kubernetes, and the other projects that I've mentioned, but I can point to Kubernetes specifically and say that Red Hat is very, very involved in Kubernetes. When I joined the Kubernetes patch mailing list, and my inbox just exploded, because we were doing so many patches per day. So that was really exciting to see that work from Red Hat. And then other projects like CoreOS come into play and work on Kubernetes. So where are we today? Right now, there are going to be 3 Atomic hosts. Now, we've had the Fedora Atomic host around for quite some time. That was the first initial test bed to try Atomic out. So we have a Fedora-based image out on our website, projectatomic.io. And it is being used basically for the development model for Atomic hosts, at least on the community upstream side. After Fedora 21, we should have Atomic host trees generated regularly for Fedora updates. Right now, the situation is there isn't anything you can actually install yet with Atomic. So when I say we have images, I literally mean we have virtual machines that you can download and try out. The problem is RPM-OS 3, even though it's not replacing RPM, it still doesn't play very well with existing tools like Anaconda, which is a big part of the installation process for RHEL and Fedora and CentOS. So you really have to get them to work nicely with each other, and we are still working on that and getting that out. So soon, we're going to have a Fedora Atomic Rawhide update, and then we will have it will be bare metal install, and you'll be able to use RPM OS 3 to, basically deploy Fedora Rawhide, which is, like any other test version, could be unstable. So imagine using Rawhide in your test environment to just sort of check it out and say, oh, that didn't work. Let's roll back to the previous version. Done. You can use Atomic to do that. Sort of a nice side benefit. And then major releases of Atomic Host will follow the Fedora releases. So we're pretty sure we're going to see an installable binary bare metal edition of Fedora Atomic Host with Fedora 22 probably coming up in April this year-ish. So CentOS, since Red Hat is deeply partnering with the CentOS team, development on Atomic Host is done in their Atomic Special Interest Group. We just released an alpha image for CentOS last week on November 6th. I'm very personally excited about this because while I have nothing against Fedora whatsoever, showing off Atomic Host for an enterprise play you're necessarily going to want to do that on Fedora. So I was really tickled to see this thing finally running on CentOS 7. We'll have regular updates with new trees coming soon. We'll also be able to have CentOS signing. We'll also have some Amazon Web Services AMIs coming for EC2 soon. And I'll have the link up on the last slide so you can go download this image. And I'll show you this in just a second. The Special Interest Group will be putting out regular releases as they become available. They won't necessarily be as time-based releases as Fedora. And then finally, the RHEL Atomic Host, which I will mention in passing. Not that I don't care about RHEL Atomic Hosts, but it is not community. It is not upstream. This is a commercial, product that Red Hat will pull out. However, if you are a Red Hat customer, we just released the public beta for RHEL Atomic Host this week as part of Amazon reInvent. In fact, I think the press release went out yesterday. And so if you go, just do a quick Google search for Atomic Host Beta, you should be able to find that for RHEL. And there are links to the download site. So with that, let me quickly, and again, I apologize for the disease. Okay, so I took the aforementioned CentOS image. There it is. See if I can get it to fit. It's really not much there. It's just basically a minimal CentOS install. It's actually kind of big. The image itself is about 1 gig. So if you look at that and say, is that his idea of small? Yes, we are quite aware that there's some trimming to be done. So it's an alpha. I'm being upfront with you and being cool about it, but it's kind of a big. So that's basically what's running over there. I got it going. Where are we at? I find the right thing. I wasn't expecting dual screens, so Here we go. So this is Cockpit, which is an easy enough thing to show you, okay? I've just got a single host, the aforementioned atomic image. And you drill down here, and you can start seeing things. Remember, Cockpit was originally designed to be a server manager tool. So you can see system information, yada, yada. You can look at your storage as you go through. Users. But down here, this is the kind of the interesting thing. We have containers. I just have a couple of containers installed here. The master images are down here at the bottom. I have an overt container that I downloaded. Thank you. And then I have a privileged instance of Cockpit. Cockpit is actually included service with Atomic Host, but I wanted to test out a privileged container and see if it worked for this demo. And of course it didn't, so we're not going to even go there. It's early days. So where's my mouse? There we go. But I'll quickly start this. And I'll give it a couple minutes. And if any of you are familiar with Overt, it's a very large, not too easy to install virtual machine management system for your data center. It's analogous on the proprietary side to VMware vSphere. It's the it's the community upstream for Rev. And it's a really awesome tool, obviously, because I'm the community guy for that. But it is notoriously not the easiest thing in the world to install. So one of our developers a couple weeks ago actually containerized it or Dockerized it and had 3.5, which is our latest release, running inside of a container, which in theory, I have to give it a couple seconds to start up. It might throw me at not ready error. Let's see if it goes. Gonna work? Yes. And I can sign in. I just have a few minutes for questions, so I won't do that. But this is an actually fully running version of Overt. And if I had decent bandwidth in here, and if I'd had more time, I literally could have downloaded this thing and had it up and running inside of 5 minutes, which is exactly what happened in my home office when I pulled this in on November 6th after we got the CentOS image. So 5 minutes to get Overt started. You know, there are other services like WordPress and Joomla and really easy stuff that you can download and have up and running in just a couple of minutes, depending on your bandwidth. Okay, and that's done with Cockpit. That's only one orchestration layer. There are more to see. There's more to show. So let me get back to the slides so I can show you the links. Yeah, of course it did that. This is what happens when I don't hit Shift F5. So I'll get back to the end real quick, and then I'll show you the links, and then we'll have time for questions. And with that, I thank you very much for your time and attention today and bearing with my faulty voice. For those of you who are old enough to remember, this has been the Peter Brady Memorial presentation. You know, I run that joke by my coworkers, and they're all babies. They're too young to understand that. So thank you. Thank you very much. So, I also have stickers, so not cool books. So what do you got?
Thanks for a good insight. How do you see Project Atomic comparing to other projects in this space? CoreOS comes to mind. The advantages or maybe the noticeable roadmap features that would set it apart.
I think the number one advantage for Atomic, and this may seem self-serving, yeah, it's self-serving, I'll admit it, is that odds are you probably got some RHEL-based systems, hopefully in your infrastructure somewhere already. So if you do, using Atomic means you don't have to shift over to CoreOS. If you don't, like if you're like a Debian-based shop or something like that, then you're free to choose either way. So that's one answer. So if you're coming from a RHEL ecosystem, this will help you stay in a RHEL ecosystem. The other part of the answer is that we're really focusing, CoreOS is a really cool and interesting project, and they are working with Kubernetes too. But we are trying really, really hard to work with a whole bunch of different orchestration layers to get this whole thing managed on an enterprise scale. And who gets it done right is really going to be, it's still early days for both projects. So I'm not going to stand here and disparage CoreOS in any way, shape, or form. But from our side, we're looking towards, getting it out there, getting a mature project out there to help people get a handle on, Docker, which is still a pretty immature new technology, But I invite you to check both out and go from there, because I got to be cool and open source about it, and I think you should check them both out. So, yes.
I've been a little confused about how to classify kind of what Project Atomic is, in that it isn't necessarily a distribution. It's, as best I can come to, it's essentially a configuration based on different projects being installed onto one of 3 possible OS variant or distros.
Right.
And so I'm kind of struggling with the Project Atomic is a blank.
Welcome to my world.
Okay.
No, literally, no.
I didn't know if
no,
this
when they ran this by me, because we announced this in June, and we've been talking about it since like February of, this year. And I had the same reaction. I'm like, what is this? It is, I think you said it well, it is a configuration. It's a set of tools that when you have an Atomic host going, it's going to basically strip out everything from the distribution that you don't need. And it's only have the tools in there that you do need to do all this container management and orchestration.
Is there a plan to continue to have, or to have a more clearly delineated Atomic edition of whatever? Or, I mean, right now there is like Fedora Atomic, but I almost get a sense that like behind the scenes there's probably an argument of like, no, we just want RHEL, Fedora, CentOS to be what they always have been, and then you can turn it into Atomic, or other people would want to have a stripped down distribution. But certainly that's one of the biggest differentiations between CoreOS. Like when CoreOS, you're going into it for one specific purpose. With
right.
Atomic, you could easily get into a position where you're like, is this an Atomic configuration Fedora box or not? Or it could be some weird kind of mutation.
But I think you actually helped answer my question to the first gentleman, is that, okay, yeah, with CoreOS, you're going to that thing for container management.
Yep.
Okay? Atomic the same way. The difference is you don't have to, if you're already running in one of those operating systems in the Red Hat ecosystem, you can stay there. You don't have to shift over and migrate to a new operating system, an entirely different distribution. You just run it on these minimal hosts. And your infrastructure, you're still going to have, because there's still going to be things inside Atomic hosts that are going to be common to the regular version of each distribution. We're not going to strip out completely everything. These are still going to be CentOS and Fedora and RHEL distros, and they will be managed as such, and you'll be able to kind of keep your existing, configuration management or whatever you need to, control these things. So that's basically the argument there. So the answer, I guess the short answer to your question is, if you want to work with containers but don't want to have to shift to a completely distribution, we're offering you another choice.
Perfect. Thank you.
Yeah.
So you said that you're always investigating new things to add to this. Are there any plans for any sort of network virtualization overlays like Pipework or CoreOS has Flannel, formerly Rudder?
I can tell you that we're looking at Flannel now.
Okay.
And we're doing that. I had it in my notes, but I decided I wasn't going to do a networking thing, but Flannel is in consideration. Red Hat is looking hard at SDN and NFV and all sorts of networking things now too, so that could be an early preview for what's coming down the road and a lot of things. So, but yeah, we're definitely looking at Flannel specifically and building that in. And we're really, like I said, since we have now a Fedora image and a CentOS image, and now the public beta, we're really hoping that people will go out to the website, download these images, start playing with this thing, and jump into the community. That's really what we're hoping that will happen, and get this whole thing going in a good direction.
Great. Thank you.
Thank you. Thank you all. Sticker.